How can we build Spring and non-Spring based communication between Kubernetes clusters and legacy systems in a way that accounts for different development languages and messaging protocols? Michael Hillman, Principal Architect at Solus, and Robbie Durham, Principal SE from the Office of the CTO at VMware, will tell us how. Now to you two.
Good afternoon, folks. I'm Robbie Jerem, Principal Architect at VMware, part of the Office of the CTO, and I'm here with Michael, and we're going to be talking about event meshes and the Tanzu platform. So, Michael.
Thanks, Robbie. So, Mike Hillman, I'm a Principal Architect with Solus. I'm part of the Strategic Partners Division, so I focus on building out the solutions with our partners like VMware around things like TKG and Spring. So I'm looking forward to sharing some of that with you guys today. All right, so I'll go ahead and share my screen. Thanks for joining us today. Move ahead. So as Robbie mentioned, we're going to be talking for the next 25 minutes or so about event-driven architecture, right? Why an event mesh is significant in simplifying its implementation, how Solus Events Mesh brings benefits to almost any deployment method, including Tanzu's Kubernetes, right, and traditional VMware, virtual machine-based environments as well. So a quick explanation for first of what we do. In short, we help companies, Solus that is, build a digital backbone that enables real-time event-driven data movement across the entire business. So you can think of the green lines here on your screen in this diagram as a central nervous system of everything that happens across your business, right? It could be an update to a backend inventory system, payment authorization, maybe it's a credit to a loyalty rewards account, right? Anything you can think of. And we help move that data across the business. Now, given that, I want to take a step back and share with you our point of view on what's going on in the market, right? That's making this digital backbone and the real-time event-driven data movement that it supports more important than ever. The world's clearly changed, right? And it continues to change. Every business has been affected to some degree by COVID-19, right? And business models are driving change in basically every industry. And this is pretty obvious, right? But what may not be quite as obvious is that we're seeing in the market today that this kind of deep and pervasive disruption is the new normal, right? And it's this new normal that's causing companies to rethink their IT infrastructure and their architecture. In fact, we're seeing the events in the past 18 months, specifically with COVID-19, as actually accelerating rather than postponing digital transformations. And new IT requirements are being brought into clearer focus, right? Or emphasized more within that context. Broadly speaking, you can think of digital transformation agendas as always having been kind of around improving digital experiences, right? For customers, partners, employees, increasing operational efficiencies to reduce costs, and accelerating innovation to move or stay ahead of the competition. On the technical side, to support those business objectives, we know that IT teams are working to enable real-time event-driven data movement for real-time customer experiences and operations, supporting hybrid multi-cloud environments to unlock the agility of cloud while maximizing the value of legacy and traditional IT systems. They're implementing solutions in a context where entire regions could be unable to operate, demand could spike overnight, supply chains could be disrupted, and things like the new curbside pickup that we've all seen could appear out of nowhere and mean the difference between bankruptcy and survival in this new environment. Enabling decoupled application architecture, so the applications and the systems and the services can scale and fail independently. And so you can easily add, adjust, move applications and services within the system without impacting the health of the system. You want to ensure resiliency, scalability, and security of these systems so your applications can handle the spikes in demand and maintain privacy. And you want to make, or they're trying to make this real-time data more readily available to more people, right? A democratization, if you will, of up to speed and up-to-date data. A powerful enabler of all these requirements is event-driven architecture, which in basic terms is a software design pattern where decoupled applications can asynchronously publish and subscribe to events via an event broker. As you know, this is different, or as you probably know, this is different from traditional design paradigms where applications are more tightly coupled and communication is more point-to-point in nature, which can create all types of problems when you're thinking about scalability, agility, and resilience as you start adding to and adjusting to these solutions. You're managing it and trying to handle spikes in load and volume. EDA supports the real-time event-driven data movement and the decoupled application architecture by design. It's inherent in the pattern, and it can deliver the resiliency, the scalability, and the data where it needs to go, provided you've picked the right broker. And all of this can be done at scale to support hundreds or thousands of applications and microservices across hybrid multi-cloud deployments. To do all that, you need to deploy multiple event brokers and connect them to form what's called an event mesh. An event mesh being a network of brokers that help you to do EDA well at scale across complex polyglot environments. And with the right management layer for this in place as well, you can make it easy for your developers and your architects and other stakeholders to find and leverage these real-time data feeds to create new and better applications that create new value faster. This is what we're seeing in the event-driven architecture. This is why we're seeing event-driven architecture become a mainstream architectural pattern, and why we believe that it will soon be the predominant architectural pattern for modern enterprises everywhere. It's being leveraged by modern enterprises now across every major vertical. So as we know, EDA well at enterprise scale can be challenging, right, for the reasons specified. And when you start thinking about complexity of modern IT environments, how do you enable or event enable legacy applications and efficiently stream those events into the cloud? Or vice versa, how do you efficiently stream events from cloud native services and SaaS and web apps back to systems on premises? It's not an easy problem to solve. And on the diversity of technologies front, how do you move events between all these different technologies, which might use a variety of different APIs, protocols, and programming languages? And questions like, how do you ensure quality of service demands around performance, reliability, and security don't suffer with scale? And then all the time keeping track of how do you support your developers in designing events and discovering events, promoting reusability? How do you optimize the choreography of these events and the data flowing through your organization? And then how do you govern it all? From our perspective, having done this for quite a while now and working with enterprises across industries and across the world, we found that they really need two capabilities to realize the full potential of EDA. Number one, you need enterprise-grade event streaming capabilities to create an event mesh. And number two, you need those event management tools, that tool set, right? And as I alluded to earlier, an event mesh is this smart network of event brokers that can dynamically route events between any and all applications connected to the mesh. And the event management tool set we have in mind is similar to what exists for APIs today, API management today, right? The tools that help EDA teams design, share, discover, promote, and lifecycle manage these events and their event streams to visualize and optimize event flows across the enterprise. So what does each broker need then to be able to handle this scenario? Native support for any protocol or programming language that you may need to support, and inherent mapping between them all. So automatic protocol transformation. Support for open standards is a must, right, across all these different protocols, and support for programming frameworks like Spring, including Spring Boot and Cloud Connector and Cloud Streams and Cloud Data Flow, and the ability to be deployed anywhere, any public cloud, alongside traditional legacy systems on-prem, and within new modern deployment methods like Tanzu Kubernetes. and support for newer patterns like IoT, and the ability to supply access to front-end systems via REST and WebSockets and the like. So when you then take these brokers and you connect them all together to form an event mesh, a couple of key features stand out. Number one is connectivity is uniform. It really is a connect anywhere capability that's real time and pub sub in its distribution. And the next one is routing is dynamic. This means that not only do routes change in real time as new subscribers and publishers come online, but data movement is much more efficient. Data is only sent if there's an active subscriber at that endpoint. Most solutions in this space need to replicate the data first, all the data for that matter, and only then decide whether or not a subscriber needs that data. And event management, again, think of it like API management. We decided to look at the API world and how they solve these problems for REST, right, or synchronous applications. Typically, there's an API portal that enables architects and developers to document and discover, register, analyze, collaborate, and be productive using RESTful APIs. The API portal then is linked to the API gateway to execute on these REST apps. We did something similar for events and asynchronous applications. We developed an event portal for designing events and schemas and applications, which then is linked to an event portal runtime where you can discover the events in your runtime to feed and evolve your design. So at this point, a fair question would be, who is Solus, right? And why would our perspective be of interest? And for those unfamiliar, Solus has been helping companies adopt, manage, and leverage event-driven architecture for over 2 decades. In 2001, we were building appliances and developing software to solve some of the most mission-critical data movement challenges on the planet, in capital markets, in gaming, and in aviation. Over the years, we've been brought in to support an increasing number of use cases in more and more ever-increasing industries. And then about 5 years ago, we set out to apply our technology and our expertise to build a platform that would give enterprises everything they need to adopt EDA at scale. And the result is the market's first purpose-built platform to enable enterprise-wide EDA. We developed through thought leadership around concepts like event mesh and event management, which are now widely used by analysts, partners like SAP, Boomi, and MuleSoft, and companies like Red Hat. We're the organizers of the EDA Summit, for which the inaugural event was this year, and it drew an impressive audience for the first year. And today we have global customers in every industry. We have offices around the world. So that being said, how does this work, right? How do you actually implement it? So we're going to cover how easy it is to deploy Solus, configure an event mesh, and then what you can do working with it with respect to event management. So I'm going to show you how to build this, right? I'm going to show you how to build a global multi-cloud event mesh simply, quickly, and reliably. First, virtually any deployment method can be used. These are the most popular, but Solus has, Solus does have a full SaaS offering that can be deployed into the public cloud or into an enterprise's private VPC. You can deploy into any public cloud manually as well if you prefer. You can pull down and spin up a Docker container, and Robbie's going to be talking to you about how to stand up Solus in TKG and within the context of traditional VMs. So if you start with the SaaS option, you navigate to cloud.solus.com and log in. Trials are free. You have the ability to create multiple Solus broker services. You can see I have about 5 here already. You just click on the create icon button. You select your quality of service, developer or enterprise in this case, with enterprise having more config options around spool connections and the like. You then select where to deploy. You can pick a public cloud, or you can select the private cloud to deploy again, as I mentioned, into a private VPC, or even into a TKG cluster that Robbie's going to talk about a bit later. Once that's done, you select your region. I'm going to select within GCP, I'm going to select Singapore. And then you name your service. Mine's named Polyglot Event Mesh in TKG for Spring 1. And then you click Start Service. About 3 minutes later, you're going to have a service ready to go. Then you can simply click on the service icon. You can see the details about the service, including its current utilization, how to connect and how to bridge to form an event mesh. By clicking the icon in the upper, in the upper right-hand corner, you can also dig into other administrative tooling. But that's it. It's that easy to stand up Solace via the SaaS, and standing up in Docker is just as easy. Note there's a GitHub repo that you can follow along if you want to do this on your own. But to walk through the summary of it, first of all, you got to install Docker and Docker Compose. Then you're going to run a git clone command, and once the git clone command is done, you're going to cd into the template directory that it created. Now, for my example, I required 2 changes to be made to my cloned YAML file. The first one is port 55555 is a default port used by Solace for internal communication. And as of macOS Big Sur release, the port's no longer available for use. So I had to change that. I chose 55558. Any port that's unused will work. And then next, I changed my current connection count from the default of 100 to 1000. And I did this so that I could ensure participation in my event mesh. So two simple changes to make: save the YAML file, issue a Docker Compose command, and within 2 minutes or so, Solace will be up and running, and you can access it administratively via localhost port 8080. You click on that default icon, and again, it takes you to the main admin tooling for monitoring and managing your Solace services. So it's that easy. Now I'm going to turn it over to Robbie real quick and let him talk to you about TKG and VMs.
Wonderful. Thanks, Michael. So that was a standalone Docker instance where it's developer focused. You can get it up and running. Let's talk more around production deployment and what that looks like. So if we can move to the next slide. Let's talk about Kubernetes, Tanzu Kubernetes grid, and what that looks like in a data center, for example. So the first step of deploying Solace is well, we need some Kubernetes. So in the data center on the vSphere platform, we can ask vSphere to provision a Tanzu Kubernetes grid cluster for us. That will deploy our TKG cluster. Part of that configuration is setting up the default persistence, which will be a data store such as vSAN by default. And then we need to deploy Solace. Solace is so easy to deploy. It's very trivial. It's deployed as a Helm-based installation. So I add the Solace repo to my config, my Kubernetes config, and I say Helm install Solace. That's going to talk to my TKG cluster. It's going to create the Solace namespace. It's going to create the persistent volumes, deploy the containers, and the service is going to start up. It's going to default to creating a service type load balancer, and expose that API endpoint for the event broker out into the real world. Of course, if I'm in the data center, there may be a few other steps there to get that to participate out of the network. Depends on the network config at that point. But at that point, Solace is up and running in the data center on the vSphere platform, on TKG. And it can ready to participate in the event mesh around the world. Equally, we can do the same kind of deployment in say, AWS using TKG. So we can deploy a TKG cluster into AWS or one of the other hyperscalers and follow exactly the same process. We'll set up Helm, we'll deploy it, the default persistence is going to be there, and we're good to go. Equally, if we want to customize that persistence and set policy around encryption or performance, we can just change the storage class, the storage policy to map to those use cases. Then the final deployment option we have here really is a VM deployment. As Michael was talking about, Solace have been building virtual machines, virtual appliances for a number of years. And this is a fairly common deployment architecture for more traditional platforms. And this is a GUI or a CLI based deployment. So here we can download the OVA. We can go to the GUI. We can say deploy the virtual appliance onto vSphere. That will create the VM. That will map it to a storage data store that we've chosen based on storage policy. And the event data is going to be stored alongside the inside the appliance. And this is a GUI CLI deployment with a step by step. but it gives you a VM at the end of it that's running the appliance, ready to participate in the event mesh. And then the final option we have, of course, is the SaaS service that Michael was talking about, where we've got Solid PubSub running as a SaaS service, and I want my Tanzu Kubernetes grid clusters to participate in that SaaS. So what I do there is I get the YAML configuration and my key from the Solid portal. I simply deploy that YAML file into my TKG cluster, and then Solid PubSub is going to do the rest. So once the agent has started, it will talk back to Solid PubSub, and that will deploy the Solid container images. It will configure up the pods, and the service will start as you'd expect it to. So we've got a number of different ways of deploying Solid on TKG and hyperscalers as a VM or as managed from a SaaS service. But we've got a consistent platform. We've got that consistent message event broker that can send messages globally inside the data center, inside the different clouds. So there's a number of different ways of doing it. Which ones should we pick? Which is most appropriate? And that's a really good question. So if we move on to the next slide, let's talk a little bit about that. So when it comes down to considerations, what matters to whom? We know the event mesh is consistent. We know that's protocol abstracted. That's a consistent platform from a developer experience. We know we've got a Polyglot environment, so it doesn't matter what language I'm programming in, the client SDKs are consistent. I've got a local development environment, Docker run, and I can start learning and I can start hacking around and building my application to use an event mesh. So what really do I need to think about? Well, platform performance is important. Messages are moving backwards and forwards. The storage matters for those environments, especially if you're handling thousands of messages a second. So that's a consideration. And tied to that is the operations, the platform teams. As an application developer, I don't care so much about the underlying infrastructure, but it's very important in production. And how that's operationalized and how that is supported is really one of the most important considerations. If my operations team that's running my application and looking after the Solid platform is a VM-only focused team, they only understand virtual machines, we can deploy an OVA and they can treat it as a VM, they can manage it as a VM, and they understand that model. So they're comfortable and they deliver a good service. If it's a Kubernetes team, we can deliver it as TKG cluster and we can manage it as Kubernetes. If it's hyperscaler, we can deploy an AWS. If it's a VMware cloud platform, a VCF or a VMC platform, we can deploy what's comfortable to them. Or if they're an anything goes platform team and they can do all of the above and they can do VMs and Kubernetes and everything else in between, and they've got a proper DevOps relationship and they can do everything, then as a developer, I don't mind. They can do whatever they like, so long as they deliver a consistent availability inside the operations for the service mesh. I can consume it in any language, in any protocol, because it's consistent. And equally, as those VM-based teams mature and become comfortable with Kubernetes, they can deploy Solid as a Kubernetes service, and they can switch off the VM without interrupting the messages, without interrupting the mesh, and to deliver that constant platform without causing any kind of outage. So the ops team can evolve without impacting the service that Solid can deliver or my application. So quickly in summary, next slide, please, Michael. That gives us the ability to deliver OVAs, TKG Kubernetes, TKG and cloud providers or public cloud to pull that mesh together. And then that mesh, that federation of brokers is what delivers that platform, no matter what data center, no matter how you've got that packaged. And with that, I'm going to hand back to Michael so that he can talk about actually configuring this up.
Thanks, Robbie. Okay, so now we've got the brokers running. How do we actually configure an event mesh? And this example I'm going to walk you through real quick is connecting one of Robbie's on-premises TKG-based Solid brokers with the one that I created in the GCP cloud in Singapore. This will be persistent and bidirectional, and that's important because one of the benefits of an event mesh is direct access to services behind firewalls on premises. Traffic outbound from the on-prem node is usually easy to support, but traffic inbound requires firewall changes that are difficult at best and not permitted at worst. Creating a persistent bidirectional event mesh connection between the on-prem UK-based node, in our case, and the cloud-based GCP node in Singapore allows any service connected in Singapore to communicate directly with a service on premises in UK. So it's easy to do. You're going to click on create a new cluster, which creates a new interface, right? You're going to give it a name, you're going to give it, assign it a password, and then click create, and it's done, right? You'll do this on the node. Once that's created, you're going to right click, create external link, which is going to connect to the other node. In this case, it's GCP Singapore. And then you're going to basically fill out the authentication mechanism. So Sol's Cloud, because the destination node here is in Sol's Cloud, we authenticate with Sol's Cloud. We can use credential. In this case, I'm going to use an API token to authenticate there. I select the default service on the TKG side, the UK side. I select the Polyglot event mesh service that I created on the Sol's Cloud side and click create connection, right? So I'm going to verify the direction and put in the passwords. And then within 30 seconds, it's up and running. So what I've done is I've created, in this case, it's a 2-broker event mesh that connects Singapore to the UK across GCP's public cloud and a private deployment of TKG, right? And one more quick little thing I want to show you here is it's even simpler than that. We've just released something in beta called the Mesh Manager. If you recall, these 3 services I had in my previously created in my instance, I've got one in the UK in Azure, I've got one in California in AWS, I've got one in Singapore in GCP. I click on Mesh Manager. When I get there, I have a search parameter. I can search and find the services that I want to include. I've typed in mesh to filter out the 3 that I want. I include those 3. And all I have to do now is, once the services have been included, is click create. And it creates this event mesh for me. So in a minute or 2, all the connections are done. So the work I showed you a minute ago to connect 2 brokers has been done automatically across all 3 brokers. And you can view details here. You can run health checks. One of the neat things about the health check aspect is a round trip latency calculation, but it's going to confirm all the services up, are they accepting client connections, and then what's the latency. And once this is all done, you can now leverage the event portal for discovery, design, and management. And I'll show you briefly, it's a couple of those slides. There's a catalog of schemas, which is fully searchable. So you can find existing schemas, create new ones, where a schema defines the payload of an event stream. Likewise, there's catalogs of the event streams themselves. Again, it's searchable. You can create new ones. And the event streams in this case are associated with schemas and with topic addresses. And then lastly, there's also catalogs of applications and services themselves. Again, searchable to find the ones that you want, or capacity to create new ones are there. And then the last aspect is what we call the graph view. And this graph view provides a visualization of how these components interact, right? And the graph view can be used to design EDA-based solutions from the top down, or you can use a discovery agent that will actually go out and identify components in an existing enterprise, an existing solution. What are the topics? What are the consumers? What are the producers? And then populate these catalogs and then manifest as a graph view of what your current environment looks like. And you can do this for a bottom-up view of the enterprise, or actually use this in an audit capacity, right, over time to design, update, change, and review. And that's it. So thanks for your time and your attention. I encourage you to explore more on your own. We've got code labs. I've got plenty of links here for assets that you can explore, and we'll be available via our office hours later today and tomorrow to do some demos or answer questions about anything you may have questions on. So thank you much.
Thank you.
Thanks, Michael and Robbie. Head over to the Slack channel for this talk to join the Q&A now.